Hey young buddies, in this session, let us learn an equation for the effective resistance in series combination. So this is an important question in a chapter called electricity that is there for 10th CBSE and all state boards of 10th class. At the same time, this is an important equation for grade plus 2 also. Let us move on to the equation part. You consider three resistances R1, R2 and R3 which are connected in series to a battery of voltage V. Consider three resistances R1, R2 and R3 which are connected in series to a battery of voltage V. When the battery is switched on, I amperes of current flows into the circuit. When the battery is switched on, I amperes of current flows into the circuit. In series combination, current remains constant and the voltage changes. I repeat, in series combination, current remains constant and the voltage changes. Let the voltage across the resistance R1 is V1, the voltage across the resistance R2 is V2 and the voltage across the resistance R3 is V3. Before going into the actual equation part, let us have a speed overlook at this. We had considered three different resistances R1, R2, R3 which are connected in series to a battery of voltage V. When the battery is switched on, I amperes of current flows into the circuit. Then in series combination, the current remains constant and the voltage changes. We had considered the voltage at R1 is V1, voltage at R2 is V2 and the voltage at R3 is V3. Now, from Ohm's law, we have V is equal to IR. V is equal to IR, where V is the voltage, I is the current and R is the resistance. Now let us write the voltages of these resistances. Now let us write the voltages here. The voltage across the resistance R1, voltage across resistance R1 is V1 and is given by IR1. Similarly, the voltage across the resistance R2 is V2 and it is IR2. And the voltage across the resistance R3 is V3 and it is IR3. We did not use I1, I2, I3 because the current I remains constant in series combination. Moving further, let us find out the effective voltage here. The effective voltage V is V1 plus V2 plus V3. Here we have V is equal to IR. So IR is equal to IR1 plus IR2 plus IR3. The next stage, IR is equal to, take I common here, we get R1 plus R2 plus R3, I and I get cancelled. So finally, R is equal to R1 plus R2 plus R3, which states that the effective resistance in series combination is equal to sum of individual resistances. The effective resistance in series combination of the resistors is equal to the sum of individual resistances. Thus, R is equal to R1 plus R2 plus R3. Now, so this is sufficient for the board exams. Now, let us add some more points so that it helps you for IIT and NEET preparation. And they are, if you observe the effective resistance being the sum of the individual resistance, the effective resistance in series combination increases. So there is a point that will be a theory bit. So the effective resistance in series combination, increases. If there are n number of equal resistors, then the effective resistance R dash is given by NR. These two may help you in IIT and NEET preparation. Learning is a celebration.